6.3 Sequence activities. Sequence activities is the process of identifying and documenting relationships among the project activities. The key benefit of this process is that it defines a logical sequence of work to obtain the greatest efficiency given all project constraints. This process is performed throughout the project. That's from PMBOK Guide page 187. In the previous process, Identify Activities, we started with a number of work packages and decomposed them into a bunch of activities. Please note that you can only decompose work packages into activities. You can't decompose, for example, planning packages. In this process, we are starting with a bunch of activities and we're going to put them into the right order. And that's why we call it sequencing. Suppose your work package is a painted wooden box. The bunch of activities would be similar to paint box coat 1, saw wood, glue wedges, nail together, paint box coat 2, measure wood, sandbox. But when you look at the list, you can see that you're not going to be able to paint the wood before you saw it to length. And you certainly would never saw wood before measuring it. In fact, carpenters have a very wise saying, measure twice but cut once. In other words, double check before cutting. And so you can see that there's an order required, which would be measure wood, 2 saw wood, 3 glue edges, 4 nail together, 5 sand box, 6 paint box coat 1, 7 paint box coat 2. Now we can draw a network diagram. Each rectangle in our diagram, which represents a single activity, is called a node. And so our diagram is referred to as an activity on node diagram. The arrows connecting the boxes are called the relationships, and we will discover these soon. It is called a PDM network, which stands for Precedence Diagramming Method, because every activity in our network has a predecessor, which means an activity that comes before it. And you can see that every activity in the network also has a successor as well. You may have noticed that there are 2 dummy activities called begin and end. This not only ensures that every activity has a predecessor and a successor, but in real projects, PDM networks are large and branch all over the place, and it can be very difficult to tell where they actually start and finish. And so adding these 2 dummy activities reduces confusion and mistakes. Now it's time to have a look at the inputs. Sequence activities inputs. Number 1, project management plan. Project management components we're interested in this process are the schedule management plan, because the schedule management plan defines the method used and the level of accuracy along with other criteria required to sequence activities. Scope baseline. The project work breakdown structure deliverables, constraints and assumptions documented in the scope baseline are considered explicitly while sequencing activities. Input number 2, project documents. The project documents that can be considered as inputs for this process include the activity attributes. Activity attributes may describe a necessary sequence of events or define predecessor-successor relationships, as well as define lead and lag and logical relationships between the activities. Whenever the activities are being defined, you usually have experts available to help with the process, but these experts may not be available later, and so it's a good idea to document relevant knowledge about the activities into the activity attributes. Think of our wooden box. Perhaps the first coat of paint needs to dry for 1 hour before the second can be applied. This means we have to wait an hour after the first coat before we put the second coat, and this delay is called a lag. And so we can record this lag in the activity attributes relating to painting so that we don't forget it later on. The next project document is activity list. The activity list contains all scheduled activities required on the project that are to be sequenced, plus dependencies and other constraints for those activities that can influence the sequencing of the activities. What is the dependency between 2 activities? If you check the PMBOK Guide glossary, it says see logical relationship. If you go to logical relationship, in the glossary it says a dependency between 2 activities or between an activity and a milestone. Thanks guys, that really cleared that up. Don't worry, we will cover dependencies in a few minutes. Assumption log. Assumptions and constraints recorded in the assumption log may influence the way activities are sequenced and relationship between activities and the need for leads and lags, and may give rise to individual project risks that may impact the project schedule. Just a reminder, when you create the project scope statement, it will contain a list of constraints and assumptions, and then the project scope statement becomes part of the scope baseline. But you will uncover new constraints and assumptions throughout the project, and then you will need to have them documented in the assumption log, and that's why we're checking it. Milestone list. The milestone list may have scheduled dates for specific milestones, which may influence the way activities are sequenced. Input number 3, enterprise environmental factors. The enterprise environmental factors that can influence the sequence activities process include government or industry standards, project management information systems, scheduling tools, and organization work authorization systems. Input number 4, organizational process assets. The organizational process assets that can influence the sequence activity processes include portfolio and program plans and project interdependencies and relationships. Why do we need portfolio and program plans? It's because relationships can be internal or external, and the plans will help you manage external dependencies that your project has with other projects. For example, another project may be building a product that your project needs to use. An example of that could be another project is building a group of houses and your project is to do the landscaping. Or your project might need specialists who are currently working on other projects, and this creates a dependency. Existing formal and informal activity planning related policies, procedures and guidelines, such as a scheduling methodology that is considered in developing logical relationships. Templates that can be used to expedite the preparation of networks for project activities. What are templates? Basically, they are plans and documents which have been used in previous similar projects, and you're going to recycle them. It's like an everyday situation in an office when you're asked to write a report, drop a plan or create a chart, and so you ask around to see if someone has something similar that you can modify. It can save a lot of time and reduces errors as long as you don't accidentally leave some of the original information in it. You can also look at previous activity attributes for more information, and you can check out how sequencing has been done previously. Hopefully you'll find these documents in the Lessons Learned repository. Sequence activities, tools and techniques. Tools and techniques number 1, precedence diagramming method. The precedence diagramming method, PDM, is a technique used for constructing a schedule model in which activities are presented by nodes and graphically linked by one or more logical relationships shown in the sequence in which the activities are to be performed. PDM includes 4 types of dependencies or logical relationships. A predecessor activity is an activity that logically comes before a dependent activity in a schedule. A successor activity is a dependent activity which logically comes after another activity in the schedule. These relationships are defined below and are illustrated in figure 6.9 in the PMBOK guide. First of all, we have finish to start relationship, FS, a logical relationship in which a successor activity cannot start until a predecessor activity has finished. For example, when we were building our wooden box, we must glue the edges before we nail the components together. So this is a finish to start relationship. In fact, all the relationships in our box making network so far are finish to start relationships. This is hardly surprising because the finish to start relationship is the most commonly used relationship. This is commonly asked in the examination. Finish to finish relationship. A logical relationship in which a successor activity cannot finish until the predecessor activity has finished. For example, with our wooden box, if you have 2 people working on it, the sawing can be done in parallel with the measuring. However, the sawing can't finish until the measuring has finished, as you will see in this diagram. Start to start. A logical relationship in which a successor activity cannot start until a predecessor activity has started. For example, with our wooden box, if two people are measuring and sawing in parallel, the sawing can't begin until the measuring has started. This is a start to start relationship as shown below. Start to finish. A logical relationship in which the successor activity cannot finish until the predecessor activity has started. For example, a new accounts payable system, the successor, has to start before the old accounts payable system has been shut down, which is the predecessor. The start to finish relationship is very rarely used, but is included to present a complete list of the PDM relationship types. Not all scheduling applications include start to finish because of its rarity. Two activities that have a logical relationship at the same time, for example, in a wooden box deliverable, the measuring and sawing activities have both relationships, and so for a full picture, here is a start to start finish combined with a finish to finish. But please note that multiple relationships between the same activities are not recommended, so a decision has to be made to select a relationship with the highest impact. And in the above case, let's consider the start to start. Nothing can happen until measuring has started. But once measuring has started, sawing can start. And then it can continue in parallel. A finish to finish would have no impact until most of the sawing is complete. Therefore, closed loops are not recommended for logical relationship. Therefore, the start to start relationship would have the biggest impact, and that's the one we should be using. But just a reminder, the closed loops are not recommended in logical relationships. Tools and technique number 2, dependency determination and integration. I just paused there, and did you notice in this particular process that the number 1 tool and technique was not expert knowledge? That is something which you might want to remember for the examination, because the examination likes to test you on the various oddities in the PMBOK guide. So we're talking about tools and techniques number 2, dependency determination and integration. Dependencies may be characterized by the following attributes: mandatory or discretionary, internal or external, but they can have only 2 attributes at any time. It's worth remembering this list for the exam. Also note that it is the project team that will determine the dependencies among the sequence activities process. Mandatory external dependencies, mandatory internal dependencies, discretionary external dependencies, or discretionary internal dependencies. Now let's have a look at them in detail. Mandatory dependencies. Mandatory dependencies are those that are legally or contractually required or inherent in the nature of the work. In exam questions, you may also see them referred to as hard logic or hard dependencies. They often involve physical limitations. For example, on our box deliverable, you must sand the box before you paint it. There's no choice. Therefore, this is a mandatory dependency. The project team determines which dependencies are mandatory during the process of sequencing the activities. Discretionary dependencies. In the exam, these may be referred to as preferred logic, preferential logic, or soft logic. Discretionary dependencies are established based on knowledge of best practices within a particular application area or some unusual aspect of the project where a specific sequence is desired, even though there may be acceptable alternatives. For example, generally accepted best practice recommends that during construction, the electrical work should be started and finished before the plumbing work. This order is not mandatory, and both activities can occur in parallel at the same time, but performing the activities in sequence or sequential order reduces the overall project risk. Discretionary dependencies should be fully documented, since they can create arbitrary total float values and can limit later scheduling options. When fast-tracking techniques are employed, these discretionary dependencies should be reviewed carefully and considered for modification or removal. What does fast-tracking mean? It means performing activities in parallel to reduce the overall time. We will cover this in the next lesson. In our box example, the measuring and sawing we're fast-tracked, we can do those at the same time. External dependencies. These involve a relationship between project activities and non-project activities. These dependencies are usually outside of the project team's control. For example, our wooden box might be dependent on the delivery of a tin of paint, and so if the paint is late, we can't progress beyond sand in the box until it arrives. Internal dependencies. These involve precedence relationships between project activities that are generally within the project team's control. For example, we can't glue the edges of wood until it has been sawn to length. Tools and techniques number 3, leads and lags. A lead is the amount of time a successor activity can be advanced with respect to predecessor activity. For example, suppose that our box is huge and will take 12 hours to paint and complete. Gluing will take 2 hours and nailing will take another 2 hours. We want to reduce the time by about an hour, so we decide to fast track gluing and nailing, but the glue has to set for 1 hour before it can be nailed. So we show it as a finish to start relationship with a lead of 1 hour. This means gluing will start and end at the same time as before, but nailing will start and end 1 hour earlier than before. This nailing has been given a lead of 1 hour and the overall phase will end an hour earlier. In scheduling applications, lead is often represented as lag, but with a negative value. Lag is the amount of time a successor activity will be delayed with respect to a predecessor activity. For example, suppose that the paint of our box needs 1 hour to dry before the second coat can be applied. We could say that there's a 1 hour lag on the final activity, paint coat 2. This can be shown as a start-to-start relationship with a 1 hour lag. Lag can be represented in project scheduling network diagrams as shown in figure 6.11 in the relationship between activities H and I, as indicated by the nomenclature SS plus 10 start to finish plus 10 days lag, even though the offset is not shown relative to a timescale. Activities and their related assumptions should be documented. For the example, please remember the use of leads and lags should not replace schedule logic. Duration estimates do not include any leads or lags. Sequence activities outputs. Number 1, of course, is project schedule network diagrams. A project schedule network diagram is a graphical representation of the logical relationships, also referred to as dependencies among the project schedule activities. Figure 6.11 illustrates a project schedule network diagram. A project schedule network diagram is produced manually or by using project management software. It can include full project details or can have more summary activities. A summary narrative can accompany the diagram and describe the basic approach used to sequence activities. Any unusual activity sequences within the network should be fully described within the narrative. For the example, please remember that path convergence means an activity has multiple predecessor activities. Path divergence means an activity has multiple successor activities. Divergence and convergence increase risk for an activity because they are affected by various activities or can affect multiple activities. Activity 1 in figure 6.11 is called a path convergence as it is more than one predecessor, while activity K is called a path divergence as it is more than one successor. Output number 2, project document updates. Project documents that may be updated as a result of carrying out this process include activity attributes. Activity attributes may describe a necessary sequence of events or define predecessor or successor relationships, as well as define lead and lag logical relationships between the activities. As I mentioned before, if you have information about activity relationships, when you first identify them, it's a good idea to record the information in the activity attributes as early as possible so you don't forget them or misremember them later. Activity list. The activity list may be impacted by the change in relationships among the project activities during the sequencing activities. Assumption log. Assumptions and constraints recorded in the assumption log may need to be updated based on the sequencing relationships determination and leads and lags and may give rise to individual project risks that may impact the project schedule. Milestone list. The scheduled dates for specific milestones may be impacted by changes in relationships among the project activities during the sequence activities. And that brings us to the end of this particular lesson, and please read the corresponding chapter of the PMBOK guide before we proceed to the next lesson in our sequence